Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, Crossing New Frontiers to Conquer Today's Challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, St. Augustine.
I'm Philip Emeagwali. On the 4th of July of 1989, the U.S. Independence Day, I experimentally discovered how to build a new supercomputer that is a new internet that encircled a globe and encircled it in the manner our planetary-sized internet encircles the earth. I experimentally discovered how to build that new internet and do so from an ensemble of commodity off-the-shelf processors that were identical to each other and that were equal distances afar and apart from each other. That new knowledge was knowing my new internet as a global network of 1,048,576 email wires that I visualized as tightly circumscribing the hypersurface of a hyperglobe in a 16-dimensional hyperspace. My experimental discovery of massively parallel processing that occurred around that new internet and that occurred on the 4th of July of 1989 made the news headlines and was reported in the June 20, 1990 issue of the Wall Street Journal. 11 years later, that experimental discovery of a new internet that is also a new supercomputer was reconfirmed by then President Bill Clinton and reconfirmed in his presidential lecture of August 26, 2000. That presidential lecture was delivered to the Nigerian Parliament in Abuja, Nigeria. For me, and by the late 1980s, Amdahl's law that de facto said that parallel processing will forever remain a huge waste of everybody's time was like a mist in the sun. On the 4th of July of 1989, the U.S. Independence Day, I experimentally discovered how an ensemble of 65,536 commodity processors could be harnessed as the building blocks of a new supercomputer to become the fastest supercomputer in the world. I experimentally discovered how to build a new supercomputer that encircled a globe and encircled it in the manner the internet encircled a globe, and build it from an ensemble of commodity off-the-shelf processors that were identical to each other and that were equal distances afar and apart from each other. I experimentally discovered how to use that new supercomputer to accurately solve excruciatingly detailed computational fluid dynamics models. I experimentally discovered how to solve the toughest problems in algebra, calculus, and physics that were named the 20 grand challenge problems of supercomputing. I experimentally discovered how to execute computation-intensive codes and do so in parallel or by solving 65,536 initial boundary value problems at once, instead of solving only one initial boundary value problem at a time. I experimentally discovered how to solve in parallel a system of coupled, nonlinear, and time-dependent partial differential equations of modern mathematics called Emeagwali's equations that I invented, that encoded a set of laws of physics that governed the flow of fluids that enshrouded the earth as the oil, water, and natural gas underneath the surface of the earth, or the rivers, lakes, and oceans on the surface of the earth, or the air and moisture above the surface of the earth. The partial differential equations of calculus is the mathematical technique we use to measure and understand how things move in our universe. The universal laws of motion of physics that were encoded into those partial differential equations explain how things move in our universe. Extreme scale computational physicists use those laws of motion to deepen our knowledge of the Earth's past, present, and future, as well as to have a surer understanding of how our universe was formed 13.82 billion years ago. The Philip Emeagwali's system of 9 partial differential equations of modern mathematics describe how oil, water, and natural gas move underneath the surface of the earth. I also experimentally discovered how to measure the previously unmeasurable speed. That quest is a mathematical journey from fiction to fact to forecast.
Insightful and brilliant lecture.